Hey everyone, this is Professor Deborah Oakley at the University of Nevada, Las Vegas School of Architecture. I'm doing the first of two videos here on image sizes and use of Adobe PDF. This is a common problem for architecture students, and it's so general that I thought I would just post this to the internet in general. So I want to start with this PDF here. This is a student submittal, and we see here the file size is 245 megabytes. And let's take a look at that. And this is what we have here. So it's a number of images. It's a very nicely composed board. You see the file size. This is an 11 by 17 sheet. Now I've gone through and you see all the images here. I've exported those images. I'll talk about how to do that in the Acrobat portion of this in the next video. But we're going to take a look at one of these images here and why the file size is so big and why this is a problem, because this is a common issue that it eats up a lot of bandwidth and extra time, and it is easily resolvable. So first off, I'm going to go to Photoshop here, and let's just do a new image. This will be a 7 by 5 image at 300 dpi. And it's just an empty white image. So I want to take a look at the properties of this image. This says that it is 9 megabytes in size, 2100 pixels by 1500 pixels. And this is the first thing to understand. The DPI on an image does not matter unless you are bringing it in from a scanner or a camera or outputting it with printing. Resolution inside of an image on a digital image doesn't make any difference. What matters is the pixel count. It's kind of like this is a lump of pizza dough. Okay, you have, let's say you have just a lump, right? And if you spread it out really, really thin, you can make a large pizza, but it's going to get really thin. That's your pixel density. So it may be starting out, if you make it this size, you have a certain density, you spread it out, and it gets smaller and thinner and thinner and thinner, and finally it can't even be continuous. But if you make it smaller, that's a higher density. You haven't changed the total amount of pizza dough, but it's the density in one place that matters. That density is corresponding to your resolution. Now let's look at the file size here. This is the actual dough. So I'll bring up a calculator here, and I've got 2100 pixels by 1500 pixels. Okay, that's 3,150,000 pixels in the image. But there are actually 3 channels. This is a what's known as an RGB image. Over at the right here, I have the channels open. We see red, green, and blue because there's red, green, and blue mixed together to get the full spectrum of colors. So I have to multiply this by 3 times. So it says it's 9,450,000 pixels. Now we see 9 megapixels up here, so the multipliers, kilo is 1,000, mega is 1,000,000. So I need to divide this by 1,000,000. But we're dealing with binary here, so it's actually 2 to the 10th power, 1024. So I'm going to divide this by 1024, and then 1024 again. And we see 9.01 megapixels is the file size. That matches. Now, this is going to be different on the disk. It depends on how it's saved. So I'm not going to make any changes to this right now. But let's go ahead and I'm going to save this as, I'm going to use, in this case, 2 formats. TIFF format, and I'm just going to use the word demo. I had already pre-configured that. And then I'm going to, let's do this, no compression. I'm going to do this a couple different ways. No compression. Now I'm going to save this again. I'm going to keep the TIFF format. And I'm going to change this to LZW compression. And let's save it one more time. Okay, now let's look at those file sizes on disk. So first off, my demo TIFF we see that it is 9.4 megabytes. That's the actual size. If I compare that with the JPEG version of that I just saved, we see that is only 106K. That's because JPEG is a compressible format, and what it does is it actually takes data and tosses it out. It's permanently removed. The second TIFF that I saved, which had a compression in it, notice that that is 57K. Now, these different formats have different qualities to them. Back in the day, a TIFF file was the only thing that printers would accept because JPEG was really bad quality. They've substantially improved it. JPEG is actually very good these days, but it does throw out information. What that means is if you repeatedly save information, you will degrade the quality of the image. TIFF that's saved with LZW compression is not lossless. It is lossless. It remembers all the data. This is a white sheet. The computer only has to say, okay, take this segment here that's all white and repeat it how many times you have. And so it takes up much less space. Now, if I were to do something like make a gradient across here, I've changed the quality. I can't say that's all white. So if I save this now as a TIFF and change that back to TIFF, we'll make this demo 2. TIFF stands for tagged image format. I don't know exactly what that means, but that's what that stands for. And we'll do demo 2 TIFF. Replace this, and let's leave the LZW compression on that because it won't change if I don't do that. All right, and the 2 TIFF, now it's 1.6 megabytes. It's gone up from 57K, almost nothing, to 1.6 megabytes. So many, many times larger, okay? Now, most people are going to be using JPEGs. And the thing is that in that Acrobat file, even though these might be put in here as JPEGs, they're going to be expanded to their full size, their full pixel density. Okay, so that's kind of the starting point. Now, let's open up one of these images here. Let's take a look at this one right here. And I've exported it as JPEG and as TIFF, so let's open that up. All right, and let's take a look at the image size here. So I've got this as JPEG and TIFF. So if I look at the TIFF image, it says it's 6.54 megabytes. Now let's look at the pixel count here, 1134 by 1511. So if I take 1134 and multiply that 1511, now again, we have 3 channels here. And divide that by 1024. I'll square that and divide 4.9 megabytes. Well, why doesn't that match? Well, that's because this image is not actually an RGB image. This is a CMYK image. RGB means red, green, and blue. CMYK means that it's cyan, magenta, yellow, and black. RGB is intended for display, so it is illuminated, it's luminance colors, whereas CMYK is cyan, magenta, yellow, and black. That is for print production. So there's actually 4 channels in here, and we see them over at the side here, cyan, magenta, yellow, and black. So let me go back to my calculator here and take my 1134, multiply that by 1511. Now multiply this by 4 for 4 channels. Now divide it by 1024 twice. 6.54. So you see that is matching the actual image size that Photoshop says it is. All right, so now you see the resolution here is 927 pixels per inch. So that's really, really dense. That means on the printed image it would be super, super tight. Now, we don't need that kind of image density for something that's not being blown up to a really large. You never need that much image density. Watch the size here. I have this in inches. Okay, I'm going to turn off resample. I'll talk about that in a second. If I change this resolution down to, say, 200, okay, most high-quality printing does like 300 dots per inch. That would be book quality printing. If you want archival, highest quality photographic prints, maybe 600 dpi, not 900 though. If I do reduce that down to 200, that says that's a 7.5 by almost 6 inch, 5.6, 5.7 inch wide image. But the pixel count has not changed and the image size remains the same. Now, if I do that instead by resampling, watch what happens to the file size. I'm going to reduce this to 200 dpi, and now it goes down to 312K, and it's only 1 inch by 1.6 inches. It's gone down from 6.54 megabytes down to 312K, an amazing amount of reduction on that. And this is right now, this is the TIFF format. If I look at the JPEG format, we see that it's exactly the same. Same number of pixels, same resolution, same total file size. Okay, so when you put an image into Acrobat, it's going to take the true file size. So you want to start out with a small file size. That is the first thing. All right, so now let's go back to the original sheet that this came from. So we have a tabloid sheet, 17 inches wide, 11 inches high. What if this sheet was 200 dots per inch for the whole thing, instead of the 6.5 megabytes per image on a very tiny image? So let's do that calculation. So it's 17 inches wide times 200 dots per inch. That means 3,400 pixels horizontally. And then it is also 11 inches high times 200 dots for that, dots per inch. That's 2,200 dots vertically. Multiply those together. That gives us 7.48 megabytes. But again, it's 3 color channels, so we got to multiply that by 3. So that's 22.4 megabytes. Now we convert that into, well, 22,440,000 bytes. Let's turn that into megabytes. 1024 squared, divide that. It's 21.4 megabytes for the entire page. That's, you know, these 3 images here almost add up to that. So you really got to be careful about your image resolution. So let's try another example. Another file I received from a student was excessively large, and the PDF came in at 267 megabytes. So there was one image here. Let's sort this by file size. We see this image 4, page 7, image 4 is 41 megabytes for one image. To put this into perspective here, my first computer had a 10 megabyte hard drive. That means this one image is 4 times larger than my hard drive was in 1985, way back in the dark ages. So let's look at the image size here. So the resolution here is 165 dots per inch. That's actually not too bad. That would be fine. But the size is 18 by 24. So this is a big image. Now, if you're going to print a poster that you want to see from 100 feet away, yeah, you need it to be big like that, but not for an archival thing. So I'd really want to resample this on the sheet. If it's an 11 by 17 sheet, that image might only be about 10 inches wide. So let's reduce the image here. I'm going to resample. Resample means that it's going to recalculate. It's going to interpolate between pixels. And it will reduce the size, but it also loses image data. So you only want to do this on files when you know what you want in the end. So I'm going to reduce this to 10 inches. I have this set to inches. And look, it goes down to 8 megabytes. Okay, so that's a dramatic reduction. So that's your first thing that you want to do with image sizes. You want to understand how big something is and how big it needs to be. Watch your resolution and think about that only in terms of the output. Okay, if somebody says, I want a 300 dpi image, it doesn't make any difference what that is until you say how big is it going to be. I want a 300 dpi image that's 10 inches wide and 7.5 inches high. That actually means something. And if you want to go up interpolation, you can do that, but you're never going to restore quality. Just keep that in mind. This is a permanent reduction of the file sizes. But for archival purposes, this is good. So this is the beginning point of understanding with your file sizes for images when you put them into PDFs.